This conference will now be recorded.
Very good evening, students. Today we'll be taking up few numerical problems as we have completed the mirror part, reflection from the concave mirror and convex mirror, etc. We have learned, and basic concept of spherical mirrors we have learned already. So today I'll take up few numerical problems. Some of them will be typically from NCERT textbook, but those are important. Some of them will be from board exam of this NCERT, like that is also based on the board exam, okay, 12th standard exam. So why I'm taking these questions, because these are actually basic questions, and from here we will be making our concept clear so that we can solve numerical problems asked in various competitive exam, which I'll be taking up little later after completing the chapter. So the first question, I'll just write it here. The first question you might be aware of this question. Okay, if you sit in a parked car, you glance in the rear view mirror, so you know rear view mirror is a convex mirror. Sorry, rear, the word, the rear view mirror. Mirror of R2 meter. That means radius of curvature is given. From where we can find out the focal length, okay? And notice a jogger. Sometimes people go for a jogging on the road, like just on the footpath. So, or maybe so here. Okay, so a jogger who are jogging and approaching the car, parked car. If the running jogger, or sorry, if the jogger is running, jogger doesn't have much speed. The jogger running at a speed of 5 meter per second. How fast is the image of the jogger moving when the jogger is at there are three parts of this question. When the jogger is at 39 meter away from the mirror, 29 meter away from the mirror, and 19 meter away from the mirror, and there is another option. So not option, and another question is 9 meter away from the mirror. Okay, so this is the full question. I'll just make you understand about the question first. Let me tell you what the question says. So as you have understood a little bit, so if you see it in a parked car and you glance in the rear view mirror of 2 meters, r is equal to 2 meters. Okay, that means, see, in the rear view mirror, you know, that is actually a convex mirror. Rear view mirror means a convex mirror, and in this case always the image will be virtual. Okay, if this is the focus, generally image used to be between pole and focus in this case. Okay, now the object is somewhere here. Okay, object is the jogger. Okay, jogger is actually jogging with a very slow speed and 5 meter per second. Okay, he's speeding, like he is running with the speed 5 meter per second, and he is approaching the parked car. Okay, or approaching the mirror. That means, you know, this object has got certain speed. This object has got certain speed. Then the question is how fast the image will move. But yeah, how fast the image will move. So if suppose the object or the jogger is at 39 meter at some certain point of time, when it is at 29 meter at certain point of time, and similarly when he is at 19 meter away or 9 meter away from the mirror. So this is actually question. So this is, you know, this is u, the object distance, which is sometime 39, 29. So these are u, and see, this is the v, this is v. Okay, this is v, object distance, and focal length for the mirror is this one, suppose. So in case of convex, so rear view mirror is convex mirror, so as I have drawn here, and see, u will be negative here, v will be positive, and also f will be positive here. So these three things you should remember. Now, so how do we solve this problem? Okay, how do we solve this problem? The simplest way to solve this problem is that, let us see, if suppose, see, we start with mirror equation. Okay, this is the answer. We start with mirror equation 1 by f. So what is the f here? F is 1 meter. Okay, since r is 2 meter, right? So u is given at every instant. We have to find out what is the value of v. So 1 by v is equal to 1 by f minus 1 by u. That means, you know, this is u minus f divided by u into f. So v will be uf by u minus f. So this is the formula. I'm just writing down here so that I can just get a clear space over here. So image distance will get u into f divided by u minus f. If we know u and f, then we will get the image distance. Okay, now look, I'll take the first part. First, I'll take the first question. When U is when this is option 1. Okay, when U is 39. So what will be the V? V will be U is actually minus, right? Minus 39 into F is 1 divided by U is minus 39. This is 1. So this will be 39 by 40. Okay, so this is the, suppose this is at certain point, some t second, okay, some t second. But just after 1 second, that means, you know, at t plus 1 second, the jogger moves 5 meter. In 1 second, he will move 5 meter towards the mirror. 5 meter towards the mirror. Towards the mirror. I hope you agree with me. I'll make you understand once again this point. See, I have taken that at any instant of time t because the time is not given. I'm just thinking that any arbitrary time t, the jogger was at 39 meter, which I have to take minus because in case of object distance it is minus. But just after 1 second of that means t plus 1 second, the jogger moves 5 meter because it has speed. The jogger has speed 5 meter per second. So in 1 second it will move towards the mirror by 5 meter. So what will be, see, after 1 second, then after 1 second, the object distance will be, object distance here, in the sense the jogger will be, let me write the jogger, distance of the jogger from the mirror. After 1 second, the distance of the jogger from the mirror is how much? That will be minus 39 and it is going towards, so this plus 5 meter, right? So it will be some 39 meters, sorry, 34 meter. So if we apply the same formula to find out, so position of V excuse me, so the position of V, sorry, so the position of V, sorry, position of image, position of the jogger after 1 second, 1 second is how much? We can use the same formula. see minus 34 into 1 divided by minus 34 minus of 1, that means 34 by 35. Okay, so we have got the position. Let us say this is V1 and this is V2. So V1 was before. See, just in 1 second it has gone 34 by 35 meter distance. So if I just take the difference in the position, so difference in position of the jogger in 1 second, that is nothing but speed, kind of average speed. Okay, so that is actually V2 by V2 minus V1. Oh, I'm sorry, V, because he is going towards the mirror, so V2 will be smaller than V1 because it is going towards the mirror. So it will be 39 by 40 minus of 34 by 35. Okay, so if we just take do the LCM, you know what it will be. So 587, it is like this. So this will be 280. Okay, so 7 into 39, and this will be 34 into 8. So you see, if we just do little bit of calculation, just small calculation, you know, this give it 9 7, you know, this 63, like this. This, okay, so this is 1 over 280. So this is actually the average speed. So the speed of the image speed of the image of the jogger is 1 over 280 meter per second when the jogger is when he is at 39 meter away. Okay, 39 meter away. Similarly, I can solve for the other distances as well. This is very simple. You know, we can just follow up this. See, first we have to find out. See, if I take another, like the second part of this, when it is at 29 meter away. So this is another point, like another section of the question. So first at particular time instead of time, so it will be, see, 29 into 1 with the minus sign here, 29 minus of 1, so this will be actually 29 by 30. Now after 1 second, so this is V1. After 1 second, V2 will be again, see, 5 meter less of that, so 24 into 1 divided by 24 minus 1. So 24 by 25. So now you take the difference of that. So we'll just do this. That will be actually the average speed. Okay, so it is 29 by 30 minus 24 by 25. Okay, this is meter per second. This will actually give you 1 over 150 meter per second. Okay, so this is meter in 1 second. So the speed will be this. Actually, this will be 1 over 50 meter after 1 second. So speed is 150 meter per second. Okay, so the second part, see, if we take up that with, see, we have done with 39. So if we just take this 19 alone, so this will give you actually, see, this will give you speed 1 over 60 meter per second. And then D, if we just take 9 meter away, then the speed will be 1 over 10 meter per second. Okay, so this is actually a nice numerical problem. Now we'll take up another one. So question number 2. This says a square wire of side 3 centimeter. Square wire of sides 3 centimeter is placed 25 centimeter away from a concave mirror. Concave mirror of focal length 10 centimeter. What is the area enclosed? What is the area enclosed? What is the area enclosed by the image of the wire? The center of the wire is on the axis of the mirror. With two sides normal to the axis. Okay, so the question is, so this is a concave mirror. So you have a concave mirror like this, okay, and you have, so suppose this focal length is 15 meter, right? Sorry, 10 centimeter, 10 centimeter. So kind of this is actually 10 centimeter, which is the focus, okay, and a square of side 3 centimeter is placed 25. So if this is 10, so another 10 will be like this. So around here the kind of this say, okay, so 3 centimeter, a square of 3 centimeter like this becomes actually, this has become a rectangle. I'm just trying to make a square, okay, like this. So this is the object distance from the pole. This is actually 25 centimeter, and see this is 3 centimeter of 3 centimeter side, okay. So here the question is, if the image is formed, then what will be the area enclosed by the image, okay. So this is u, actually this is u with the minus sign over here. See, how do we solve this problem? We have to see for the image what will be the sides in the image. So what we have to find out, we need to find out the size of the sides of the square. This is the main thing we have to do, so that we get the area, okay. So how to find out the size? Size means height, right? So look, this particular height, if I just take this particular side of 3 centimeter height, okay, and see if the image is formed, I can just get the position of the image somewhere. I can get the position of the image, right? This side we know, so we know the height of the object. If we know the position of the position of the side, then I will be able to find out the magnification. So magnification is actually given by h2 by h1, that is given by minus b by u, isn't it? I hope you are just getting the point. See, I know h1 is the 3 centimeter side is 3 centimeter. Now if I find out the position of this 3 centimeter side, this particular side itself, then I know the object distance. If I find out the image distance v of this particular side, which is just made bold, then I will be able to get the size or sides of the image of the square from this particular formula, okay. All right, so then it will be done. Let us do that. So u is given here, minus 25. What is f? F is minus 10 here. Okay, we have to find out what is b. B is actually 1. I'm sorry. Yeah, we can do that. See, b we had just done in the previous problem itself. So we know this is actually f into u divided by u minus f, right? So this we can use as well. So here f is minus 10, U is minus 25, then minus 25 minus plus it is, so this is actually 250 and this is minus 15. Okay, I hope I'm going okay with this. Five 3. So I get minus 50 by 3. Anyway, I have got the position. Yes. So it is the position of the image, because in case of concave mirror, the image will be formed in that side itself, because we will get the real image of that. Okay, so we have got the V. Then what is M? M is again minus V by U, minus V by U. Okay, so minus V by U means here minus of 50. See this V and U both are negative, so this will be negative side will be remaining. Okay, so V is 50 by 3 and U is 25, so we get 2 by 3. Okay, minus 2 by 3 we have got, and this image can be written as, see, image height by object height. This is equal to minus 2 by 3. Okay, so you look here, what we are getting, H2 is equal to minus 2 by 3 into H1. H1 is how much? H1 is, H1 is the side, okay, side of the object, that is 3 centimeter. So this you will get minus 2 centimeter. Minus in the image means it is, see, image I'm getting H2 as minus, that means it is inverted image. Okay, so inverted H2 is equal to this. Okay, so we have got the size now. Okay, image size, that means you have got this image of the square. Okay, so the okay, therefore the sides of the image will be of 2 centimeter. Okay, so what will be the area? Therefore the area enclosed by the image of the square will be 2 square centimeter, right? That is 4 centimeter square. Okay, this is the answer actually. So this was also a very nice question. Sometimes this question will be given like a, see, there will be a rod kind of that. So what will be the position of the image, or what will be the length? Will there be a change in the length? If this is L, so what will be the image length, etc., will be asked sometime. Okay, so we maybe will take one more problem. Okay, one or two more problems. Question number 3. What is the distance of an object from a concave mirror? What is the distance of an object from a concave mirror? sorry, what, sorry, this is actually when the distance, sorry, the question, the language is a little different. When the distance, when the distance of an object from a concave mirror is decreased from 15 centimeter to 9 centimeter, the image gets magnified. Three times than that of the than that of that in the first case. In the first case, calculate the length of the mirror. Calculate the length of the mirror. When the distance of an object from the concave mirror is decreased from 15 centimeter to 9 centimeter, the image gets magnified by 3 times than that of the first case. Length of the mirror? No, I'm sorry. This is calculate the focal length. Sorry, this is focal length of the mirror. Focal length of the mirror. It is very simple, right? Calculate the focal length of the mirror. So there are two object distance. You can see that U1 is 15 centimeters, U2 is 9 centimeters. See, it is, say now H2 is 3 times the H1. This is what is given. So how do you find out the length? In fact, the M is given, right? Magnification is given. So see, here two object distance are given. Can we find out magnification in terms of focal length and object distance? Answer is yes. See, 1 by V plus 1 by U is equal to 1 by F. See, if I just multiply, say I want to make it U, so let us multiply with U by V plus 1 is equal to 1 over F. So V by U will be actually, so this is 1 minus F, so this will be minus 1, so 1 minus F divided by F, so F by 1 minus F, 1 minus F, right? So magnification is, magnification is minus V by U, so it will be F by F minus 1. Oh, sorry, this is not 1, actually this is U, this is U minus F, so it will be F minus U. Okay, this is actually magnification, right? So it is for the concave mirror, so U will be positive, sorry, negative, F will be also negative in this case. Okay, so anyway, if we don't know the value and all, it may be virtual also, don't know that, because here it is, yeah, it will be virtual because it is magnified 3 times. 3 times magnification means it may be virtual image also. We don't know. We'll just go with the sign of U itself. Okay, so magnification. When the M is this, see when is so let us write in two cases. So what are the aims, so this is aim. Magnification is okay, 3 times magnified. M, suppose m1 in the beginning, like when it was 15, so this will be actually minus 15, this is minus 19, so f by f minus of minus, this is 15, and when it is m2 is also f by f plus 9. Okay, so just go there. So m1 we have got f by f plus 15, and m2 we have got f by f plus 9. Okay, now see if here is a magnified, 3 times magnified means m2 will be actually 3 times of m1. Okay, 3 times magnified it is said. If the distance decreases, then the image gets magnified by 3 times. So m2 will be 3 times of m1. Okay, so we can actually get the ratio of these two. So m2 by m1, this is 3, right? And this is equal to f by f plus 9, f plus 15 divided by f. So this f will get cancelled. So 3f plus 27, this is f plus 15. So this will be 2f is equal to minus of 12, and hence f will be minus 6 centimeter. Okay, and this is actually focal length of the mirror. So minus 6 centimeter is the focal length of the mirror. Okay, we have few more time, like maybe 10-15 minutes or more. We'll just go with another numerical problem. So this was the question for, this was a good question actually. And then let me take one question which was just few minutes back I was speaking of that kind of question. This was being asked in IIT 19. Okay, IIT 19. Question number 4. This question: a thin rod of length, a thin rod of length f by 3 is placed along the optic axis of a concave mirror of focal length f such that its image which is real and elongated just touches the rod, what will be the magnification? So this is the question. A length of rod, a thin rod of length f by 3 is placed along the optic axis. If I draw the figure, this is with the concave mirror, right? Just say this is the concave mirror. So this is the pole. All the distances will be measured from here, as you know that. So let us say this is focal length. So 2f will be this one, somewhere here. Okay. Now the question is that the thin rod of length f by 3 is placed along the optic axis of a concave mirror of focal length f such that its image touches the rod itself, and the nature of the image is said to be real and elongated. Okay, so the image of the rod is placed along the optic axis, which will touch the rod, right? Only when, and this happens only when the end of the rod is at the center of curvature, because you know the image will form at the same point when we keep an object at the twice of f or at the center of curvature. See, if this is the center of curvature, and if we keep the object like this, then only it is possible that the image will have it here. So whenever this question comes like this, you have to understand this, the object must be placed at the ends. Actually, the rear end must be placed at the 2f. Okay, so that image will have its front end at that particular position. Otherwise, it is not possible to touch the rod. So this is f by 3. This is the object, and this is the image actually. Okay, this is the image. This is the rod. This is the image. Okay, this is the image. All right. So this is elongated. We have to find out the magnification. Okay, this is what the question is. You know, I hope you have understood this. So why I have taken this rear end at this particular position, because the image will start from here. If I would have kept like this, then the image would have had this end somewhere else. Okay. Okay. So reflection will have, see, rear end first, isn't it? So this is kind of inverted image, real and inverted image. So this is why I have to keep this ends. C, suppose this is CA. So this here it will be C prime A prime here. Okay, kind of that the image will be. All right. So the question is, what is the magnification? For magnification, we have two formulas, like formula is to by h1 or minus b by u. So you have to go with any one of this. Okay. At least we know the object distance now, right? Do you know object distance here? We know the size of the image also, object also, but we don't know the image size, right? Anyway, so what we have to do, we have to find out the image position. Okay, we have got the object position. So what is the object position? So object position we have to take up to here. Actually, this is object position. So this is f, 2f minus of that. Okay, so object position is minus 2f minus of f by 3. This is my object distance. 6, so 6f minus f, so 5f by 3. Okay, this is actually the object distance. Okay, what is the image distance? We know the focal length is given as f. So we can find out now 1 by v is equal to 1 over f minus of 1 over u. So this has both are actually in case of concave mirror, both are negative. So this f I'll take as negative. Okay, if I take that as negative, okay, so yeah. Anyway, we have to find out the magnification. This fine. So we'll just get it here. See 1 over f minus of 1 over this. So we have got this, right? So 1 over f with a minus sign over this is positive 5f by 3. So 3 minus 5. So okay, let me just go to the next page. So we have to find out 1 over v is equal to 1 over f minus 1 over u. So with the minus sign if we take, then it will be 1 over f plus 1 over u. So u is again, u is obtained as 5f by 3. So 1 over f plus 5f by 3. Okay, so this is actually 3f here, 3f. So this will be 3 plus 5f square. Okay, I think it will be better not to go for the calculation here itself. So let us just do the tricks over here. Let me just multiply u, let me multiply u both side. Okay, 1 over v is equal to 1 over f plus 1 over u, right? Let me multiply u by v plus u by f plus 1, right? So this will be, if I want to make it v by u, then I would get 1 so u plus f down, f will be u plus f. So f divided by u is 5 by 3f, sorry, 3 by 5f, 3 by 5f plus f. So this will be actually f divided by 8f by 5. So v by u is something like 5 by 8. So this is actually magnification. Okay, 5 by 8. Okay, so I think there is, okay, let me see that. All right, actually we have to find out V itself because there is some disagreement with the answer. Let me just do it here. 1 by V is equal to 1 by F minus of 1 by U. So this will be actually 1 by F plus 1 by F. F since it is not given as given with sign. Okay, look, let us just take this itself. With this itself, let us take. So this is actually 1 by U, right? It is 5F by 3. I think, let me just check. 5F by 3. 5F by 3. U was 5F by 3, so this will be 3 by 5F. 3 by 5F. Okay, so it would give you 2 by 5F then. Okay, now V is obtained, the position of the image. Where is the object position? So this is 5 by 2 into F. This is the image position. What is the length then? So it will be actually magnitude of, magnitude of this V minus U. This will be the length of the image length. Okay, length of the image will be 5F by 2 minus of 5F by 3. Okay, so this would give you 5F common. So this will be 3 actually. 6, so it is 3 to 1. Okay, so this is actually 6 like this. Okay, oh, I see this. Just a minute. Okay, I have to take the length. I have to take the length from here to here. Okay, I'm sorry, this is not 5 by 3. Actually, this is not the U actually. The image length has to be taken as, see, I'll show you from the figure, that would give you a better idea. So look here, the image length will be, see, this is the C point or C prime. Okay, so this actually you have to take C prime A prime, this length. Actually, this is 2F, and this is the image position we have got now. Okay, so we have to take this difference. Okay, so image position is this 2 by F and minus 2F it is. This will give you F by 2. Okay, F by 2. So what will be the magnification then? Size of the object, size of the, I'm sorry, size of the image and size of the rod. Size of the rod. I'll just recap what I have done in this. Size of the image is actually F by 2. Size of the rod is F by 3. So this is 3 by 2, that is 1.5. So this will be the magnification. See, I just, because we have done a little mess in between. So what we have done here, see, a thin rod of length F by 3 is placed along the optic axis of a concave mirror of focal length F such that its image which is a real image and elongated. Real image and elongated just touches the rod. So this task can be only possible when at least one side, or the, I should say not at least, this is the rear side of the rod must be touching the 2F or center of curvature, so that the image of that itself will be formed here. Okay, the image of that particular side will be forming here, and the other portion will be forming this side. Okay, A prime. So this A is become A prime and C has become C prime itself. So this is why we have to take, see the image position, see the position of this particular guy, this particular point A. Position of this particular point is actually, this is the object distance I have taken. I have taken the object distance means this A point. Object distance is the A point. See, that is actually at 2F minus F by 3. This is the length of the object. So this is object distance, right? That means this point will form an image where I have got the image position is here. So where it is, we have got this image position at 5 by 2F. So 5 by 2F at this particular position. Okay. So I have got now the image position of this point. Okay. I know the position, other side of the position will be at 2F, and see this is the image position here. Now if we take the difference between these two, then I will get the length of the image. I know the, see, we have done that itself. So 2 by F minus, sorry, 5 by 2F minus 2F. So because this is the position of the rear side of the image, right? So this side will form here itself. So this is one side, this is another side. Okay, that's why 5 by 2 minus 2F. So that would give you F by 2. So this will give you the image length. So what will be the magnification? Magnification will be size of the image to the, it is actually ratio of size of the image to the size of the rod, right? So this is how we have solved this question. Okay, so with this we'll stop it here for today. Next class we will take up refraction of light. Okay, total internal reflection, then application of various total, like application of total internal reflection in various cases, and then we'll try to take up few numerical problems on that particular part, and then in the next class we'll just talk of the refraction through spherical surfaces. Okay, so next class will be on the reflection and TIR. Okay, so thank you for your patience. Bye for today.